Lesson 16 is on the converse of the Pythagorean theorem. So let's first start with what the Pythagorean theorem is. So our Pythagorean theorem deals, remember, with side lengths of a right triangle. Okay, so we can say if the lengths of the legs of a right triangle are A and B, and the length of the hypotenuse
Going to bed?
is C, then A squared, A to the second power, plus B squared is equal to C squared. Okay, and I know that seems really long, kind of confusing, but it's important because we want to talk about the word converse, okay? And converses come into play, you'll learn later on, with if-then statements, okay? So it says if the lengths of the legs of a right triangle, remember the legs are the ones that make up the right triangle, right angle, are A and B, and the length of the hypotenuse is C, then A squared plus B squared equals C squared. Then we have that formula that we can find missing side lengths, okay? But when we talk about a converse is when we switch the if and then parts around. Now we don't switch then and if, but we switch all of the words that come after if and all the words that come after then. Don't be too confused. This is what it means. If a triangle with side lengths A, B, and C satisfies A squared plus B squared equal to C squared, then the triangle is a right triangle. And hopefully you can read my writing. Okay? But again, the difference now is that before we were told that it was a right triangle. We were told that, and so then we could use A squared plus B squared equal to C squared to figure out what of the missing legs or the missing hypotenuse. Now we're having the side lengths, and the question is, okay, is it a right triangle? Well, if we can prove that A squared plus B squared equals C squared, same rules apply, C has to be our hypotenuse. If we can prove that's true, then yes, we can say it's a right triangle. Okay, so that's really what we're focusing on today is our converse here. Figuring out if triangles are right triangles. Okay, so be careful when you're going through these that you read the questions. They might be worded maybe a little bit differently. Just meaning like sometimes it is still going to be asking you for missing side length and sometimes it's going to be asking if it's a right triangle. So let's look at this example. Is a triangle with leg lengths 3 miles and 8 miles and a hypotenuse of length square root of 73 miles a right triangle? Show your work. Okay, so you totally don't have to draw a picture, but I do feel like it's easier sometimes to get a visual of it. Remember, legs are the sides around the right angle. So if I designate this to be my right angle, I'm going to put 3 miles here and 8 miles here. Okay, and that would mean our hypotenuse is across from the right angle, square root of 73. The other thing's going to be a little different with these is we're not going to just have integers we're working with. We're working with the square root of 73. Remember, if it's not a perfect square, it's an automatic approximation. Okay, so here's what we do. You are going to use your Pythagorean theorem. But we're going to put a question mark above that equal sign. Okay, so I'm going to fill in my legs. 3 to the second plus 8 to the second does that equal the square root of 73 to the second? So that's a little weird looking, isn't it? Just keep going down. 3 squared is 3 times 3, which is 9, plus 8 squared, 8 times 8 is 64. Now notice we have the square root and squaring. Those two things undo each other. If I take the square root of 73 and then square that number, I'm right back to 73. So if you go 9 plus 64, you get 73. Does 73 equal 73? Check. So is it a right triangle? Yes, this is a right triangle. Okay, so again, question's a little bit different than what we're used to. Now, remember I said, be careful reading the questions. Don't just assume things. It says, what is the length of an unknown side of the right triangle shown below? So we're dealing with the missing side length, right triangle, Pythagorean theorem. So we have to go back to making sure we understand what gets filled in where. Find your right angle, draw an arrow to the side across from it, that's your C. So we have a 4 and a 1 here. It doesn't matter which one you plug in for which. So I'm just going to put 4 in for A. So 4 squared plus 1 squared equals C squared. 4 squared is not 4 times 2. Remember, it's 4 times 4, which is 16. 1 times 1 is 1, equals C squared. 16 plus 1 is 17, equal to C squared. Okay, so now it says provide an exact answer and an approximate answer round to the 10th place. So remember, when we solve this, we're not solving for C squared. How do we undo squaring something? Well, we take the square root. Whatever we do to one side, we do to the other. Okay, so when you square C and then take the square of it, we're left with just C. And our exact answer, 17, is not a perfect square. So our exact answer is the square root of 17. But then we can also approximate it. And so when you type that into your calculator, you get 4.1231 ... But it does say to the 10th place. So the 10th place where the 1 is. So I look at the 2 behind it. The 2 either tells me to stay at a 1 or move up to a 2. It tells me to stay at a 1. So we get the approximate answer of 4.1. Our exact answer and our approximate answer. Ooh, sorry. That's even messier than normal for me. Okay, so again, read the questions. Make sure you're asking what the question is, or answering what the question is asking, answering it. One more example here. What is the length of the unknown side in the right triangle shown below? Length, right triangle, Pythagorean theorem. Show your work, provide an exact answer and an approximate answer. So again, real quick, because this is just like the last one, I find my C. Very important to do. So we have 6 squared plus 2 squared is equal to C squared. 6 squared is 6 times 6, which is 36. 2 squared is 2 times 2, which is 4, is equal to C squared. That's 40. So again, remember, we need to know what C is, not what C squared is. So how do I undo squaring something? Well, I take the square root. Whatever I do to one side, I do to the other. Okay, and we get an exact answer, square root of 40. Now, I should have done this in the last one, but I kind of knew it didn't have any perfect squares. Does 40 have any perfect square factors? Remember, we do an exact answer. We don't want to just leave it like this. We want to pull out the perfect squares. So remember, if you're looking at your perfect squares, you know, kind of starting near 40, we have 36, 25, 16, no, 9, no, 4, yes. Okay, and again, guys, where are those numbers coming from? It's our list of perfect squares. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. So I'm going to break this down into the square root of 4 times the square root of 10. So the square root of 4 is 2, and the square root of 10, does 10 have any perfect squares besides 1? No. So we have 2 square roots of 10. So this right here is our exact answer. Now, our approximate answer, we just type into a calculator and again round to the nearest tenths place. So our approximate answer, whether you type in the square root of 40, 2 times the square root of 10, you get is approximately equal to, I think it ends up being 6.3. Oh, I'm sorry, these are millimeters. Okay, so the new part today is that we're going to be answering if things are right triangles or not, and we're also going to be finding exact answers. So we're going to have to pull out perfect square factors.